actually going to be focusing more on quadrilaterals and the midpoint theorem, but we're going to start at a place where we need to understand how to do all of that in order to get to the proofs around quadrilaterals. So we're going to start all the way in the back. We're going to start with congruency. I always have this problem, guys. The one textbook that I used for reference says congruency, and another one that I used uses the word congruent with an E at the end. So I'm going to be using these in turn. They both mean the same thing. It's just some of them say congruency, some of them say congruence. I don't know which one it is, guys. English is not my mother tongue. So whichever one I use is the one that I use.
I think we should follow the one that has, I think we should follow the one with like from British, like with the British background in terms
with
of
the British. Okay, I'm gonna have to look that up because I'm not sure which one the British one is, but we'll see. So if I mistakenly say congruence instead of congruency or congruency instead of congruence, you guys know what I mean. We're talking about the same. Okay, all right, we're gonna do a quick recap. Okay, these are our three angles that we know normally occur when. When can we use these equivalents, guys? When can we use corresponding alternate angles and interior angles? What do I know about my lines? What needs to be happening with my lines? You guys can pop this in the chat. That's it. So that's exactly what I'm looking to hear. Okay. When we use corresponding alternate and interior angles, we need to make sure that our converse line, this line over here, through to parallel lines. So whatever lines we're looking at to make this comparison, these two lines need to be parallel to each other. Otherwise, we cannot make this comparison. Also, if this is called AB and this is called CD, if I were to say that this angle over here is equal to this angle, I need to finish that off with the proof that I can actually do this because AC is parallel, or AB is parallel to CD. So it's very important that we write this last part over here. Where did we get the alternate part, or where did we get the corresponding angles from? From the fact that AB is parallel to CD. They're not equal, they're parallel. And that's something completely different that we'll be talking about as well. All right, I want you guys to tell me quickly here. We're going to be answering question A, B, and C. Okay, as you can see, we already have parallel lines over here. I would like you guys to give me an answer for X in A. So we're looking for the answer for X over here, for X over there, and for X over here. Okay, you can pop your answers in the chat once you've got them. Have a look at them quickly. We are looking for the values of, let me actually highlight them so you guys know. And remember, you cannot just tell me X is equal to this. You need to tell me as well why it's equal to that. Oh, I'm so sorry, Kimototo. Try staying with us for as long as you can, please, my sweetie. Don't try and run away. Join in where you can. Remember, everything we're doing today is a recap of grade 9 maths, so it shouldn't be too difficult. Okay, so even if you miss something, you can still keep up. Okay, I'm sorry about that. I know South Africa sucks. I didn't say that out loud. That wasn't me. I hope the government isn't listening. I didn't say it. It wasn't me. Okay. Well done, Ntanta. That's exactly it. Good. I can see my Z there or my N. If you want to say Z or N, I usually say Z. There it is. That's Punzo even added which two lines are parallel to each other. I appreciate that. So hi, T-State, so no problem. We just started. Okay, good. So we know that X is equal to 59 degrees. And our reason over there is alternate angles. And we also need to say here that CF is parallel GJ. Hello, Palisa. Amazing to have you with us again. Okay, Makulwe says it's because it's alternative, okay? Not alternative, just alternate, okay? Alternative means something else, okay? Not alternative, and now I'm writing alternative. Just alternate, Okay, alternate means on the other side, on the other side. So if you say alternative, it means something in replace, we're replacing that. No worries, Palisa, we just started. That's okay, Winako. Okay, excellent. Let's have a look at B, guys. Tell me, what is the answer for B? This one is also quite easy, I think. Not difficult at all. Hello, Kiseto.
How are you, ma'am?
I'm good, thank you. How are you?
I'm good, ma'am.
What?
If I may not be wrong, I think the answer of B is 72.
How did we get to 72?
For my side, ma'am, I think you see those in that angle. Maybe it might be adjacent or
I'm not sure. Let's have a look again. Because remember, we're looking for either a U, so our x must make up the U like that, but our x is on the outside of the U. So the U isn't going to work for co-interior angles. And then for our corresponding angles, we need an F. Yes, we need some sort of F written like that.
so.
If I do this, there's my F. There's my F there, looking this way. But if this was 72, then my X would need to be on the inside over here in order for it to be equal to 72. And also, it doesn't work because this line over here isn't sitting in the correct place. It should be parallel. So that doesn't work. If the U and the F doesn't work, which other one can we try? Okay, so we know that corresponding and co-interior angles don't work. What other one can we use? What's the last one? I agree with everyone who's saying alternate. Yes, that's it, Mohammed. Look, if we look here, there is my Z. You guys see it? Okay. I'm lying. I'm even lying to you guys because those are not the parallel lines. You use the actual parallel. This is my one parallel line, and this is my other parallel line, and then this is the. Oh, so I'm correct. So this angle over here would be equal to this angle over there. Means they're not actually, it's not actually 55. That one here on the inside. How do we figure out that one? Lipe, you are onto something there, my sweetie. That's it. That's what I was looking for. Okay. Okay, somebody saying, ma'am, could you please repeat? Yes, absolutely, I can repeat that. All right, so when we are looking at, excuse me, these comparisons, we can look at these two like that being our Z for alternate angles. But the two alternate angles would be this one and that one. That one is 55. The one between HK and F. There. That one is 55 degrees. How do we figure out what X is from that? How do we figure that one out? It's going to be, as Lisa said, these two angles, this one and this one, will be angles on a straight line. So what would that answer be? Okay, we have to go X plus 55 degrees is equal to 180 degrees. My reason would be angles on a straight line. Good, or supplementary angles, whichever one you call it. Therefore, X will be equal to 125 degrees. Very well done, Like. Nicely spotted. I saw somebody already giving us the answer to the last one. I want you guys to have a look at that last one over there and tell me and see what would we get for C in this case. What is the answer for X over here? Okay, look for the shape that we're looking for. Yes, Tisetso.
And I think it's gonna be x plus 60 degrees is equals to 180 degrees, if I'm not being wrong.
Okay, we've missed one. Okay. Remember, here is my parallel line. This one and this one. So if I want to use this, I'm gonna have to use all of them on the inside. So that x plus 60, what else must be plus there? Plus?
41.
Good, plus 41 degrees. Plus 41
Sure.
degrees is equal to 180. And what's your reason?
Co
Oh,
income. Ishmael.
the last one. Did you forget the name? There it is. Okay, there's something missing here. Here it is.
Co-inter angles.
Good. Co-interior angles. That's the name I'm looking for. Excellent. So this one is co-interior angles. I'm sure so from now you can solve for x for me. Yes, give me an answer for x. Therefore, x is equal to, just transpose everything over to the other side and give me an answer.
79.
Excellent. 79 degrees. Nicely done, Tisetso. Excellent. We just need to remember the names of those angles. Okay. Corresponding, co-interior, alternate, but you did that so beautifully. Thanks, Mom.
Thanks, ma'am.
Sure. All right. Okay. Just a thumbs up. Okay. Thumbs up, thumbs down. Remember, how are we feeling about alternate, corresponding, co-interior? Remember, guys, we've done corresponding, co-interior, and alternate since grade 7. So if we're still having problems with it now, we're gonna have issues. It's been since grade 7, guys, since grade 7. So we must already be at a different kind of level. Okay. Okay, very nicely done, guys. We're going to quickly look at congruency. And I've said congruency now, okay, instead of congruence. So hopefully I continue on this vein. All right, you're gonna have to practice. Okay, all right. So there are a couple of rules that we need to know for congruency, especially in triangles. Now, this only applies to triangles because that's where we're looking at it from. But any two shapes can be congruent. Okay, who can remind us, what is congruency exactly? What does congruent mean? What does congruent mean? That's okay, Makuluwe. Excellent. I'm not gonna take that because similarity is something else completely. Okay, oh yes, I agree with you. Okay. Congruent means the same, but I like Tembelise's one even more. Tembelise says they're not just the same, they're identical. Oh, I like that. Identical. Okay. But I want you guys to tell me, what do we mean by identical? Funzo, I like that one. The way that you put it there is exactly what I was hoping to hear. It's not that they're just identical. Everything about them is identical. The sides are exactly the same length. Angles are exactly the same length. So when we're talking about congruence, okay, the sides and angles must be exactly the same. They must be exactly everything about them. Now, the problem is sometimes we're not given all of the information that we need, and we can always look at this. You can always look at this from certain points, viewpoints. So we need to make sure that when we are looking at these kinds of situations, we are making sure that when you call congruency in triangles, we're making sure that we have the relevant information. Now, the sign for congruency, right, okay, is normally this one. This one is worldwide. So there are 3 different signs. we're going to use the one that everyone in South Africa is more familiar with. So there's this one that they've shown us over here in the drawings. There's another one that looks like one line and then a squiggly line. Or you can do this. You can go 1, 2, 3. Now, the South African convention uses this one. The 3 lines that go like that. 1, 2, 3. So that's the one we're going to be using when we're going to be describing congruency throughout. Okay. And there are only really 4 cases. It's actually 4 cases or 4 rules for congruency. We're going to look at it as 5 on the screen, but I'll explain why it's technically only 4. Okay. All right. So the first rule that we can use is side, side, side. And this tells us that if all 3 sides are equal to each other, that's automatically going to tell me that the angles are equal to each other and that the shape is going to be the same. The angles are going to be the same. The reason for this is because when triangles have the exact same dimensions, the way that they're going to touch each other on each side is going to force them to have the same shape or the same size of angle. So if I take this side that is equal to this side and I connect it to this side that is equal to this side, and I connect it to this side that is equal to this side, automatically the angles are going to align because the way that the shape is put together will force the angles to be the same size. Okay, so this is one case for congruency. The next case that we're going to look at is side, angle, side. Now, it's very important for us to recognize that this is specifically saying side, angle, side. You guys notice how the A is in the middle of the 2 sides. So it's side, angle, and then side. So when we look at this, we need to think of 2 sides and an included angle, plus an included angle. Okay, what that means is if this side is equal to this side, and this side is equal to that side, they are only congruent if the angle in between the 2 sides are equal. If this side is equal to that side and that side is equal to that side, and these 2 angles are equal, that doesn't tell us about congruency because that tells us that this last side over here is not going to be equal. The one is going to have a longer side. Okay, so when we talk about SAS, it's very important that we write it exactly that way. The angle must be included in between them. So it's 2 sides and then included angle. Okay, it must be included. All right, the next one we look at is angle, side, angle. And again, look at where the angle is sitting and look at where the side is sitting. The side is sitting where? In between the 2 of them. So the side is sitting in between. So we've got angle, and the side that touches both of the angles, that includes the side. Okay, are you saying compatible? Yes. Okay, I agree. Like a combo. Yes, they must be compatible. You said, so what are you trying to say? Because you've tried to write it 3 times now, and I'm not 100% sure where you go. Okay, so for congruency, I need angle, and the included side. Okay. Again, we can also have angle, side, and also over here, angle, and side. Now, watch how it says this angle is the same as this angle, and the side touching the 2 of them is exactly the same. So because these 2 angles are equal to each other, both of them are touching the sides that are equal to each other. If this one over here had this side equal, then this would be. Okay. So whichever side the angle is touching needs to be the same in the other triangle as well. Okay. Then we've got this last one over here that says right angle, hypotenuse, and side, which again is almost like angle, like it's a side angle side situation, but because it's a right angle, and we've got an hypotenuse right across from our right angle, and the same side touching the hypotenuse equal to each other, then that makes it congruent. Somebody says, what is AAS? AAS is angle, angle, side. Angle, angle, side. And then remember that these two, this angle and side, these last two need to be the same in both triangles. Okay, AAS is angle, angle, side. Okay, now again, like we were saying, guys, side, side angle, not sufficient, because when the only time that will be sufficient is if that's okay. Okay. Side, side angle is wrong, so we cannot use side, side angle. And the reason for that is because if I have a side over here and I have a side over here, this angle can be whatever it wants. It can be this big, and if I have another side over here and another side over here, if I choose to make this angle smaller, it doesn't make sense. So we cannot have side, side angle. Side, side angle doesn't work, because even if these two sides are equal to each other, we don't know what the size of this angle is going to be. Okay. So we cannot use side, side angle is not included in part of congruency. I'm just gonna say whichever one. Okay, whichever one works for me. Whatever one lands on my mouth is the one that I'm gonna say. Okay, somebody says, ma'am, can you please repeat the explanation of RHS? Okay, R stands for right angle, and then remember, if I've got a right angle, I'm going to have a hypotenuse, which is opposite my right angle, and then one of the corresponding sides. Now, have a look here. If I've got the right angle and the hypotenuse, the corresponding sides must be the same when they are touching my right angle. They must be equal in size. All right, can I get a thumbs up? Are we okay with the rules for congruency? Because we're going to have to start using them now, and we need to remember them. Again, guys, this is a recap of grade 9 work. So we need to be very comfortable with what's happened on the screen because we've seen it. Excelente. I love it. Love it, love it, love it. Awesome stuff. Okay, so if you haven't yet, make sure that you've taken a screenshot of this if you don't know the rules, because we're going to be using them now. We're going to use them. Okay, excellent. Okay. Everybody's got their screenshot? Let's get going. All right, challenge number 1. Okay. I want you guys to tell me, yes or no, are the following 2 triangles congruent or not? And give me the reason why you say so. Are they congruent? Yes or no? And why not? Okay. Okay, let's start with number 1. Okay, I see everybody saying yes. Tisa, so what do you think?
Yes, ma'am. I think yes.
Okay, good. If you say yes, you need to give me the reason. Which rule for congruency are we going to use here? I know. Okay, remember, guys, SSA is not a rule. It's not a rule. Which one is it? Tabang, what do you think? It's not SSA. What is it, Tabang?
It's side angle side, ma'am.
Good, excellent. It's side and then the included angle and
Easy, too
excellent stuff.
easy.
Easy stuff.
Too
Very nicely
easy.
done, Tabang. That's exactly what I was looking for.
Too
Okay.
easy.
I'm glad you're enjoying it. Awesome. Okay. Okay. Excellent. Tabang's got the right answer, guys. It's sides, 2 sides, and the included angle, the angle that's in between them, it's included in. We say side, side angle. Which angle? Which one of them? It doesn't say. So we need to make sure that we're using the correct rule, guys. That's why I said take a screenshot. Okay, we need to remember side, angle, side. Okay, good. Let's have a look at number 2. Is number 2 congruent or not? Yes or no, guys? He says, I'm not sure about RHS because I'm looking at number 2 and there's no right-angled triangle. Okay, Mawanda is using that same rule that we can't use again. Okay, for those of you who say no, you need to be able to explain to me why not. Lisa says, yes, side, side, side. I'm seeing somebody else say angle, side, angle. Okay. Tabang, what do you say? Oh,
Ma'am, I think it's angle side. Wait.
What do you mean?
I think it's angle side angle, ma'am.
Which angle?
The I see both angles and then I see a side. But
But
because
it doesn't say anything about the angles being equal to each other, does it?
no,
Because this
it does.
this angle is
The
close,
angles
huh?
are equal, ma'am.
Where does it say that?
2 and 1, the angles are equal, ma'am. So
No, this one is called C1 and this one is called A1. That doesn't tell us that.
okay.
Mhm. That's all. They're only
Ah.
just labeled. What else? What else can we look for? Think about it. Okay, so they're telling me that this side is equal to that side. You agree with me?
Yes, ma'am.
And this side is also equal to that side. Agree?
Yes, ma'am.
Okay. Anything else that we can look at here? What do you notice about? What do you notice about this side over here?
Ma'am, is it gonna be angle side?
Mhm. Okay. What this tells me, Tabang, is that this AC that we're looking at over here is common. It's a common side. If it's common, doesn't that mean that it's going to be equal in both triangles?
Yes, ma'am.
Yes. So what is my reason for congruency actually over here?
Hmm.
Look, side and a side, so definitely a side. And then another side and another side, so definitely a side. And what do we know about AC? It is common,
Angle.
therefore
Yes, a side.
it's a side. Good. So my reason is going to be
Side.
side.
Oh,
You see
okay.
how I did that?
Yes, ma'am.
Okay, keep that in mind because we're going to come back to it in just a. All right, well done. Well done for trying. I love that. Keep putting your hand up. I want to hear more of your voice. Okay,
Yes, ma'am.
excellent. All right, let's have a look at number 3, guys. What do we think? Congruent or not? And what is our reason?
Oh my God.
Honey says yes. Useleta also says yes. Give me a reason, guys. Okay, I'll give you a hint. This little square in the middle tells us why. Aha, that's it. Okay, I'm seeing it. Good. Everybody knows what that little thing in the middle means. It means RHS. Good. So this is yes. You could also say side, angle, side, but in this case, or no, we actually can't say side, angle, side. We have to say RHS because the angle is opposite our hypotenuse. So we have to use RHS in this case. We cannot use side, angle, side. RH. That's the reason over there. Okay, what about number 4? Let's have a look at number 4. Now, I want us to take this a little bit slowly. I want us to do this together just to make sure that we're understanding how we can prove if something is actually congruent. Okay, so, okay. Hi, Kama. It's awesome to see you again. All right, we're going to take this one step at a time. Okay, so we're going to go, I've got an angle and an angle, right? So I've got an angle. I've got an angle that's the same, right? And then I've got an angle and an angle that's the same. But look at where the equal side is. Remember, if we want to use angle, side, this angle over here needs to be attached to the same side. Is this side attached to this same side over here? Yes or no, guys? Are they attached to the same angle? No, they're not. No, they're not. So we can't say angle, angle, side. We can't. So are these two particular triangles congruent? No, no, they're not, because they do not have what we're looking for. They're not congruent. Okay. No, they're not. Okay. So we need to make sure that we're getting the same idea going. Okay. As we go along. Okay. Now have a look at number 5. Let's have a look at number 5. Okay, we're going to take it the same exact way. Okay, I know that my square over here means right angle. Good. So we already know that we've got a right angle. I know that my hypotenuse is opposite my right angle. Good. So I've got a hypotenuse. Excellent. But let's have a look at our sides. Are our sides on the same side as my my right angle? No, they're not, because this one is at the bottom and this one is on the side. So I don't have a third side. So is it congruent? No, it is not. Okay. I hope it's making a little bit more sense, guys, in the way that we look at whether it's congruent or not. Okay. Now let's have a look at this last one over here. Okay. I've got a side over here and I've got a side over there. Cool. So I've got a side. Yes, no, Lazi.
Hey, ma'am.
Hello, my sweetie.
I wanted to ask that, is ma'am saying it's the same, so it's not?
It's not. Sorry, say that again for me, my sweetie.
I'm asking if ma'am is saying if the sides are not the same, then that means that is not congruent.
Yes, absolutely. So remember, the right angle needs to be exactly like the side that is equal to the right angle needs to be the same. Now, if you look at this one, if you look at this, my right angle is adjacent to this one on the left-hand side. And if I look at this one, it's adjacent to it on the right-hand side. Are they adjacent to the angle on the same side?
No, ma'am.
So are they going to be congruent?
No.
Okay. So are you understanding?
Okay, thank you, ma'am.
Excellent, excellent stuff. All right, let's have a look at this last one. I'm glad that you're understanding my video. Okay, we're gonna have a look at this last one over here. Okay, now I've got my side and my side, good. And then I've got my side over here and my side. Okay, I've got side and side. Now let's look at this angle that they've given us. Now, the one with two things in this triangle, the side with two lines is next to my angle. And in this triangle, the side with one line is next to my angle. So do I have an included angle over here? No, I don't, because I don't have an angle that is right next to the side that I needed to be next to. So is this one congruent? No, it's not. Okay. I can see we're going to have a bit of confusion here. So I need you guys to tell me, give me a number from 1 to 10. Do you understand how well do we understand the idea of proving whether things are congruent or not? Hi, Kama. Oh my goodness, it's going to be so great to hear your voice. I haven't seen you know what? How are you doing, my sweetie?
I'm good, and you?
I'm good, thank you. How have you been?
Yeah, a lot, but yeah,
That
no,
sounds like a story right there.
I'm fine. I think I'm really not sure.
That's okay, my sweetie. Take it a day at a time. Okay, what's up?
Ma'am, I was gonna
Yes.
ask, are we doing Euclid?
We're doing Euclid now.
Okay, thank you so much.
Excellent. All right. I know some of your schools may be doing functions now, but according to the new annual teaching plan that was released like 2 months ago, we need to do Euclid and then functions. So some of your schools haven't caught up with that. Okay, I'm seeing varying numbers, but we're going to continue and make sure that we actually 100% understand what's happening. And the crux of what we need to be doing in grade 10 is we need to be learning how to prove. Well, we're actually going to be focusing on proving quadrilaterals, but before we can even do that, we need to learn how to prove congruency. Okay, so we're going to look at this over here. Okay, and I'm going to show you guys how we're going to do it. And then we're going to take it from there together. All right. So we're going to read all the information that we've been given. Remember, whenever they write anything at the top, read it. Read. Okay, we're going to start at the top here. It says, in quadrilateral ABCD, remember now the order in which it is written is going to be important. ABCD. We need to remember that. Okay. It says here that AB is equal to BC. And as soon as they say AB is equal to BC, this means that they're talking about size. Okay. If they give you a parameter CD, G8, they're normally talking about two sides being equal to each other. So now this says AB is equal to BC. Let's make sure they've done that on the drawing. AB is equal to BC, correct? Okay, they've done that. And then they say AD is equal to CD. Let's make sure they've done that on the drawing as well. AD is equal to CD. Okay. Then it says, prove that triangle ABD, triangle ABD is congruent to triangle C. Now, look at the order in which they've written it, guys. Have a look at the order in which they've written these triangles. They say triangle ABD. So we're going to start at A. We're going to go from A to B to D. And that's how we're going to close off our triangle. And we're going to make sure that that is congruent to C, B. So we're going to start at C to B to D. And then close that off. So when we make a comparison, we need to make sure that AB is compared to CB. We need to make sure of that. And we need to make sure that BD is compared to BD. Okay, and the last two that we need to be aware of is that AD, A and D must be compared to CD. I'm going to do that again, and I'm going to use different colored highlighters just so we remember the order. Okay. Now, the order in which they give us our triangles is very, very important. They say triangle ABD. So we need to go to our triangle and make sure we start at A, B, and B. Close off our triangle A, B, D. Then from there, it says we are proving that that is congruent to triangle CB. So we're going to go start at C, move to B, and move. So we need to do it in that exact order. And what that tells us is, when I'm looking at my two triangles, AB must be compared to the first two letters in this triangle must be compared to the first two letters in the second triangle. So that must be compared to CB or BC. It doesn't matter in which order we write it. You can say AB, C, BC, but again, you understand. Okay. And then we're going to look at BD being compared in this triangle to BD in this triangle. Then the last thing we're going to do to finish it off is we're going to take the first and the last. So AD must be compared to the first and the last, CD. Okay. So we need to make sure, guys, it is in that order. For congruency, for similarity that we're going to do next, we need to make sure it is in that exact order. Okay. Now it says that we need to prove that they are congruent. So the first thing you're always going to write, and you're going to remind me, we always write proof. Start by writing proof. So if you're following with me on a piece of paper there, you're writing with me, start by writing proof. Okay, you're going to write down proof. And then you're going to write it exactly the way they've given it to you guys. Please don't make up your own things. Write it the way that they've written it. Triangle. In triangle, you see that they've gotten the order correct. A, B, D, and triangle, C, B, D. Guys, please make sure you're getting the order correct, because the order is the one thing that's going to allow us to compare the two. Okay. In triangle ABD and triangle CBD, then we're going to grab our highlighter. It says here AB, so I'm going to go to this and I'm going to go AB. Which side is AB going to be equal to on my other triangle, guys? Tell me in the chat. AB is going to be equal to which side? AB is equal to, that's it, good, is equal to CB. Good. AB, excellent. I love that. Nkanta, I need to have a look at, yeah, concentration. I love it. Okay, AB is equal to CB. Excellent. CB. Then they want to know AD. Okay. Makulube, have a look here. Makulube, look. Okay. If in this triangle, I highlight the first two letters AB, like they do over here, I need to go to the other triangle and highlight the first two letters. Okay. That's how we make it CB. AB is equal to CB. My reason for this, guys, my reason for this, and you see how they've written the little brackets for me. My reason for this is that it's given. They've given it to me. They've told me that AB is equal to BC or CB. So for my reason, I can write given. Amy is already jumping the gun, already telling us which one is next. Good. Now they say AD. So we're going to go into our triangle and we're going to go A and D. Do you see how we skipped over B and we went from A to D? AD needs to be equal to, let's look at this triangle, CD. Good. It needs to be equal to CD. CD. And my reason for that, again, they've given it to me. AD is equal to CD. It's given. Now, the last one says BD is. And we'll figure it out. That's it. They say that BD is equal to something. What do we notice in both of our triangles? Okay, good. It's given, right? I've got BD here, and over here I've got BD. What does that tell me about BD in both of these triangles? That it is common. Excellent, guys. Just mwah. Mwah. They all have BD, Kamu. Therefore, BD is common. BD is common. Okay. Whenever two triangles share a side, we say that that side is common. Okay. Good. So we say that BD is common, but we're not done. The last thing we need to write is, and now you guys understand why ma'am has always been saying, it's the therefore. Therefore, triangle ABD is congruent, 3 lines, 1, 2, 3. Triangle ABD is congruent to which side? Before we even go there, Funzo, triangle ABD is congruent to which triangle? To triangle, in the correct order, guys. Triangle ABD is congruent to triangle what? Thank you. CB. Okay. Then we can just go read off everything that we've done over here to figure out what our rule for congruency is going to be. We know that AB and CB are a side, so this is side. We know that AD and CD are both sides, so this is a side. And BD is a common one. It is a common, it's not a common angle, it is a common side. So what is my reason for congruency over here. Side, side, side. Side, side, side. Give me a thumbs up or a thumbs down. How are we feeling about what just happened? Because this is the exact order in which I needed to happen, guys. Okay, not even just me, the whole mathematical community around the world, they needed looking like this. Okay, yes, Angel. Angel, I'm going to need you to unmute for me, my sweetie, and we can have a conversation. Okay, if you're having trouble unmuting, then I'm going to ask you to write down your question in the chat. Takani and Nolwazi, please tell me in detail in the chat where I lost you. Okay, tell me in detail where I lost you, okay, so that I make sure that I don't miss out on explaining to you. Okay, oh, excellent. Angel's actually giving us a thumbs up. Excellent stuff. Latita, you too. Okay, because we're going to do another one of these. All right, it's your turn. Now, let's have a look at number one. I'm going to help you guys through this one. Just make sure that we remember the steps. Okay. Hi, Nolwazi.
Hi, ma'am.
How
I
we doing?
got lost when you.
When I said?
So, ma'am, when you saying how to prove, you said we should write proof. Then I had a network problem, so that's why I got lost. Because when I got back,
Okay, so all we need, Nolwazi, is to make sure that this statement is made. Okay, we need to make sure that this kind of statement is part of how. Okay, I'm going to show you how we do it in this next example. Okay.
Okay, ma'am.
Excellent. All right. Okay. Okay, I'm trying to mute you. It's not working, but we're going to restore. Okay, guys. Now, have a look. Remember, guys, the order is very important. It says here, prove that triangle ABO is congruent to triangle BCO. So we need to follow them in that order. So we need to start ABO, close the triangle, and then BCO, close the triangle. Okay, now, first thing we're going to do, we're going to start by saying, don't forget, proof. Always start by going proof. Anybody want to put their hand up and tell me what comes next? Anybody remember what comes next? Yes, Tembelite. Proof, and then?
Proof in triangle ABO.
Beautiful. In triangle ABO.
And triangle DCO.
Beautiful. DCO. I forgot my triangle DCO because I'm running out of space. Mwah. Excellent, Tembelite. Amazing stuff. All right. So we need 3 statements. Remember, that's how we're going to prove it. Either going to be side, angle, side, or side, 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 whatever it's going to be. We're going to need 3 reasons. 1, 2, 3. Okay. Now, Lita says that angle A is equal to angle D, and that is because of alternate angles. And I'm going to agree with Lita, but Lita forgot one very important thing. You're correct. Angle A is equal to angle D. And my reason over here is going to be alt angles. Okay. What did we forget to write? Alternate angles. And Funzo, you did it so beautifully for me last time. What do we need to remember after writing that it's alternate angles? What do we need to state, guys? We're forgetting. Mohammed, I think you meant 01, okay, and I agree with you, and it's not very opposite. I know what you were trying to say. I know what you were trying to say. It's not very opposite, but I agree. Okay, guys, please don't forget. As soon as you say alternate angles, you need to tell me which 2 angles are parallel. And we know that this means that AB, that's it, Klebo. Good, AB. on AA. AB is parallel to CD. Good. Don't forget that. Okay. Mohammed, you are on point. You must, yes, thank you, teacher Nels. You must always state the parallel lines, guys. Don't forget. Number 2, Mohammed says O1, angle O1 is equal to angle O2. And I'm sure it's not supposed to be very opposite angles. You're trying to say vertically opposite. Vert-op angles. Vert-op angles. There we go. I need reason number 3. Who's got a reason number 3 for me? What is my last reason? Remember, angle, we can't have angle, angle, angle. Angle, angle, angle is not a reason. I've got an angle here, and I've got an angle here. Okay, I'll give you guys a hint. What does this line mean? What does this line mean? Good, Karen. That's what it means. It doesn't mean parallel. The arrow means parallel, Ntanta. Okay, the line means that the sides are equal. Good. So I can say here that AB is equal to AB is equal to CD. And my reason over here is that it's given. They gave it to me. They told me on the drawing that it's equal because they showed the 2 lines. They gave me that. So I can then say, therefore, okay, remember now this is the side. Therefore, triangle ABO in that very order, guys, is congruent. 3 lines, 1, 2, 3. Triangle DCO. My reason, I've already got my reason. It's written on the side. Angle, angle. Okay. Out of 10, because we've reached the end of our lesson for today. Out of 10, how are we feeling about the proof of congruence? Because we are going to need it as we go along. So let's us add a 9. I'm seeing an 8. I'm seeing a 7. Mohammed is very comfortable. Yes, Kama.
Hi, ma'am.
Hello, Ms. Reed.
Sorry, would you mind if next lesson we could just like revise this one again? Because I feel like I got lost.
We're gonna start with it again. Okay.
Okay.
And it's just very important for us to remember the steps. Okay, I want everyone, including you, Kama, take a screenshot
Yes,
of
ma'am.
what I've got on the screen. Quickly.
I've already done that.
Excellent. Okay, everybody take a screenshot. Go try number 2, number 3, and number 4. Okay, and then we
Sorry,
can
ma'am.
compare in the first lesson. Okay.